In this video, I will talk about the kinetic energy, the total kinetic energy of a solid object of the real model. So in introductory physics, we typically model everything, or I would say in the vast majority of cases, for the vast majority of problems, we model things as points, as point particles. When that is true, for kinetic energy, you use 1/2 mv squared if the speed of the point particle is much less than the speed of light, or you use gamma minus 1 mc squared if your particle is moving very fast compared to the speed of light. Now, in cases where we have a solid 3D object, and sometimes we call that the real model, that is not only exhibiting translational motion, but it also exhibits rotational motion, then we have to treat it we need to do a little bit more work to find the total kinetic energy. So what I mean here, let's say that I have this disk or sphere, any solid object. It doesn't really matter what shape it is at this point. I want to illustrate. So, and let's say that this is moving in this direction. So it has some linear velocity, but in addition to that, it is also spinning. Okay, and let's say since it's spinning this way, it will have an angular velocity that goes out of the board. So it's doing two things: translating due to the linear velocity and also spinning with some angular velocity. And let's say and then it reaches, after some time, it reaches this point, and then it just keeps going. Okay, so that's the velocity, and it continues to spin. It keeps spinning. The way that we're gonna find the total kinetic energy of this object, so EK total, this is how I'm going to do it, and this is going to be the kinetic energy of the whole thing. This will be of the real model, or if you want, the entire 3D object. So this is how I'm gonna do it. I will say the total kinetic energy of this is equal to EK translational of the center of mass. So this is due to the translational motion of the center of mass. Okay, which means for EK translational, I'm looking at the center of mass. Now I'm assuming the center of mass is here. I'm looking at how this moves. And the center of mass is just a point. So to calculate EK translational, I will use 1/2 mv squared, assuming that this thing is not moving very fast compared to the speed of light. So I'm looking at the translational kinetic energy of the center of mass, which is a point, and I'm gonna calculate that, typically 1/2 mv squared. Now, because I know that this thing is not only moving, not only it is translating, it's moving in some direction, but also it is spinning, I do need to add EK rotational. And this is due to the rotational motion around the center of mass. And the expression that we have to calculate EK rotational is 1/2 I times the angular speed squared. You can see it is analogous to 1/2 mv squared. Instead of the inertial mass, I have the moment of inertia I, and then instead of the linear speed, I have the angular speed squared, but it has a similar form from what you can see. So When you have a solid object and it is exhibiting both translational and rotational motion, you have to calculate both. You have to take both into account.